In this recording, we will look at the topic, direct proportion, and then inverse proportion. So I'm going to use this table to describe direct proportion. We have the top row, the amount of chocolate bars, and the cost in pounds at the bottom. Now, as you can see, as the amount of chocolate bars increases, so does the cost. And it's for every one increase in the chocolate bars, the cost increases by the same amount. So these two variables are in direct proportion. Now, what is that amount? Well, if we know 3 chocolate bars cost £1.80, well, what's the cost of one chocolate bar? So 0.660p. That is what we call the constant of proportionality, because that is the amount it goes up by. So we could have a formula for cost. The cost is equal to 0.6 times, we'll call A the amount, and the cost is C. So C is equal to 0.6A, because if we did 0.6 times 4, we would have £2.40, the cost of 4 chocolate bars. Okay, see if you can use this formula to work out the cost of 11 chocolate bars. So A here is 11. So the cost would be £6.60. Okay, so how do we work out the amount of chocolate bars when we know the cost is £15.60? We can use this formula again. So C is £15.60. We don't know the amount of chocolate bars. How do we work out what A is here? How do we reverse? We divide both sides by 0.6. 26. So 26 chocolate bars cost £15.60. Okay, this was an example to show you when two variables are in direct proportion. So what you have to remember is there's a constant of proportionality, which is the amount that is the constant increase, or I suppose it could be decrease, but it's a constant increase here. So usually you'll get a very algebraic question, which we'll look at now. I think it's useful for you to see a question with two variables in direct proportion in real life. Okay, let's just have a look at these graphs before we move on. Have a look at these graphs and have a little think which show the two variables in direct proportion. So hopefully it shows graph 3, because we have a straight line. It shows a constant gradient, a constant increase. The rest of them are curved. Okay, so this is more like a question you would see in maths on the topic of direct proportion. I'm going to show you how to set these out correctly. So y is directly proportional to x. So we would write y, this funny symbol here, means directly proportional to. If you just get used to setting this out in the same way, you kind of get used to how to work out these questions. So from there, before I even start looking at the questions, I would put y is equal to kx, because k is constant proportionality. And as we saw with the chocolate bar example, this is the amount of the increase. Okay, so what we're going to do is use this information to find k. Always start with finding k. So when y is 24, x is 2. To find k, we're just going to simply divide both sides by 2 to get k is 12. So find a formula for y in terms of x. So it means we need a formula with y and x in and a number. We'll go back to here and we'll use this as our k and replace k with 12. So y is equal to 12x. B, find y when x is 12. So y is equal to 12x. Let's always start by writing out the formula. So y is equal to 12 times, let's substitute a value for x in here. 12 times 12, 144. Find x when y is 96. Let me just write my formula down again. Y is equal to 12x. This time I'm replacing y for 96. Divide both sides by 12 to get x by itself. So 96 divided by 12 is 8. X is 8. So we have A is directly proportional to B. And then A equals KB. When A is 12, B is 5. I'm going to use that information to find K. A is 12, B is 5. If I divide both sides by 5, K is 2.4. So my formula for A in terms of B, A is equal to 2.4B. I've used this formula here and just replace my K for 2.4. Find A when B is 12. I know A is 2.4B. So A is equal to 2.4 times 12. 28.8. C, find B when A is 43.2. I know A is 2.4B. I'm going to divide both sides by 2.4. So B is equal to 18. Okay, so I've got 4 questions we have to have a go at on direct proportion. Put me on pause, have a go at them and unpause when you're done. Question 1. A is directly proportional to B. A is equal to KB. 12 is equal to K times 3. Divide both sides by 3. K is 4. My formula, A in terms of B, A is equal to 4B. I know A is 4B. Find the value of A when B is 5. A is equal to 4 times 5. A is 20. And C, find B when A is 36. So replace A for 36. Divide both sides by 4. Gives us B is 9. Divide both sides by 5. 125 divided by 5 is 25. So my equation for C in terms of D, we've used a different word here, means the same thing. C is equal to 25D. Find the value of C when D is 10. I know C is equal to 25D. So 25 times 10, C is 250. Let's see. Find the value of D when C is 75. Divide both sides by 25. D is 3. Okay, these next two questions are direct proportion in a slightly different style, but it's the same idea. So y is directly proportional to x, complete the table. Y is directly proportional to x. Then we can write y is equal to kx. Right, these are unknown values. We'll sub those in to find k. So 72 equals k times 12. Divide both sides by 12. K is 6. Doesn't ask for our formula, but our formula is y equals 6x. So when x is 4, y is equal to 6x. So 6 times 4 is 24. And when x is 9, 6 times 9, 54. Question 4. This is more of a wordy question. The cost, £C, of hiring a car is directly proportional to the number of days it's hired, D. C is proportional to D. C is equal to KD. When D is 5, C is 180. So let's find K by dividing both sides by 5. K is 36. There's our formula. C is equal to 36D. A, find the value of C when D is 3. C is equal to 36D. So 36 times 3. C is 108. And then B, C is equal to 36D. Found the value of D when C is 100. Divide both sides by 36. 2.7. Okay, that's direct proportion. We're now going to look at inverse proportion. So look at these 5 pairs of numbers labelled A to E. So these represent coordinates, x and y coordinates. I put them in a little table because it might help you see the relationship more easily. So first of all, as you can see, when the x variable increases, the y variable actually decreases. And it's not by the same amount. If you look for the difference 2, 3, 4, the difference in x is 1, but the difference in y is not the same. If you might have noticed, they actually all multiply to give 36. So that's really your equation for inverse proportion. Xy is equal to the constant. We usually write it as y is equal to the constant over x, which is just the same formula rearranged. Okay, so let's just have a look at how to apply that to a question. Suppose B is inversely proportional to A. This time, for inverse proportion, we use that symbol. We write 1 over. So B is inversely proportional to A. And then when we involve our K, B is equal to K over A. Suppose we know that when A is 12, B is 60. So B is 60. Let's just replace this information into our formula to find K. So B is 60, K over 12. How do we make K the subject here? We times both sides by 12. So K is 720. To find a formula for B in terms of A, we know K is 720, so we will replace that here. So for part A, B is equal to 720 over A. B, find A when B is 90. Let's just write our formula out first of all. So B is equal to 720 over A. Right, so we need to make A the subject here. We don't want to be A to be on the bottom of a fraction. I'm going to times both sides by A first, which gives us 90A is equal to 720. And now I need to divide both sides by 90. A is equal to 720 divided by 90. A is 8. And then here, find B when A is 180. So B is equal to 720 over A. So B is 4. Okay, we've got 2 questions on each page for you to have a go at. Put me on pause, have a go, and unpause when you're done. So Y is inversely proportional to X. Y is equal to K over X. When Y is 12, X is 4. Times both sides by 4, K is 48. My formula connecting X and Y is equal to 48 over X. Find the value of Y when X is 9. So 48 divided by 9, 5.3 recurring. So for B, Y is 5.3. And for C, we have Y is equal to 48 over X. So this time we have Y is 3. Times both sides by X gives us 3X is equal to 48. Divide both sides by 3 gives us X is 16. Question 2. A is inversely proportional to B. So A is 20, B is 5, times both sides by 5 gives us K is 100. So our equation for A in terms of B, A is equal to 100 over B. Okay, part B, find A when B is 10. A is 100 over B. B is 10, so A is 100 divided by 10. A is simply 10. And find B when A is 8. So we have A is equal to 100 over B. A is 8. So let's times both sides by B first. 8B is 100. Divide both sides by 8. Gives us B is 12.5. Okay, question 3 and 4. 3, we have a time taken to complete a job is inversely proportional to the number of workers. So T is equal to K over N. When 6 workers are used, the job takes 15 hours. So the time taken is 15. And Number of workers is 6. So to get K, times both sides by 6, K is 90. So our formula is T is equal to 90 over N. Find the time taken with 10 workers. So for A, T is equal to 90 over N. Just need to replace our N with 10. Gives us T is 9. And for part B, the number of workers needed if the job takes 9 hours to complete. The 9 equals 90 over N, times both sides by N. Divide both sides by 9, gives us N is 10. So number of workers needed is 10. P is inversely proportional to Q. I think this should say P and Q. So we have to use this column here to find K. So it should be 8 here, shouldn't it? 8 is equal to K over 10 times both sides by 10. K is 80. So your formula is P is equal to 80 over Q. So when P is 16, P 16 is equal to 80 over Q times both sides by Q. Divide both sides by 16 gives us Q is 5. And then for this last part, P is equal to 80 over 20, which is 4.